Hello everyone, Assalamu alaikum. Welcome back to my channel. So if you haven't subscribed yet, just click the button and hit the bell icon so that you can get in touch with my latest content. So this is part 3 of the 3-part video series for this layout related lab. So in which we are going to dive deeper into Cadence Virtuoso and also create the layout for the inverter and test it. So previously we successfully made a symbol for our inverter, and then in part 2 we created layout. So in the previous video you must have noticed that there were some layout related issues, but in this part, after performing DRC check, we will assure that our layout is accurate. So in this part we will be performing DRC check, design rule check, layout versus schematic check, and also we will extract parasitic resistance and capacitance from the layout and perform transient simulation of this extracted view. Now, first of all, we are going to perform the DRC rules check by Cadence Ashura. Now we would execute Ashura technology, and in the following window you need to type the path of Ashura technology file as shown, and after finding this path you just need to click OK. Then execute Ashura run DRC. A DRC window will appear. Fill out the form as shown. Then click OK. So a DRC completed window will appear. This process takes some time. So after completion of this DRC run, a DRC completed window will appear. Just click yes. And now comes the important part. This is the error layout window. This will appear. You just need to find out what part has what type of error. So what you need to do is just click on that error and then press on this right arrow, and it will take you directly to the layout and point out what is the mistake. Most of the times you can tell what is the mistake, and you can correct that by hand by increasing or decreasing the width or spacing that is required by the design. So let me just quickly go through all these errors, remove all these errors, and I'll get back to you. Now, as an example, just look at this one. This first one states that this wire, there's an error in this wire. Metal 1 must connect to metal 2 with this length of greater than equal to 2 via this space, and it should be less than equal to 2. So whatever this error is, if you click on this right arrow, it will take you directly to the error space, and it will point out actually the error, what the error is. Most of the time this error will be of the spacing or the width. The requirement is not accurate. So what we will do is just change these widths and spacing according to the given requirements, and we're good to go. So just follow along, and hopefully it will be easy to resolve these types of issues. And don't worry, you might get different errors, or you might, if you are really accurate in your design, you might not get an error at all. So it all depends. Now if your design was error free, you should get this no DRC errors found message like so. After removing all the errors, it's not that difficult. Just follow along with what error is and what spacing or what width is required, and you'll be okay. The next thing that we are going to do is LVS check. So for that we are going to click Assura and then run LVS. Now this window will open. You just need to select this particular technology library. Make sure that you have your particular library selected. Okay, and most of the items are already set. Just make sure that these are the definitions that are selected. If there is any change, just do according to this given scenario. Just click OK. It will take some time and run an LVS layout versus schematic, and if there is no error, then it will display a no error message. Otherwise it will display if there is an error and let you know. So you can see that this LVS check was completed, but you can see in the log there is some unmatched internal nets error. That is just simply because if you remember, we changed our PMOS width to 240, that is equivalent to the NMOS, which is not the CMOS design. So we need to change it back. So let's just do that and let me get back to you. So this was just to show you that how to read and correct the errors. Okay, so this is unmatched internal nets error. So after removing that problem of the parameter mismatch, you can see that there are no more errors. So if there is an error in the connections or in the schematic or in your layout, if there is any kind of mismatch, it will show up here and you can debug it accordingly as you have seen in the video. So this was how you perform LVS check. Now let's move towards this parasitic extraction. So what we need to do is on our layout, just run Assura, open run, and then select this error free file which was selected previously. It is already kind of selected here, so I will click on OK. Then I will again click on Assura and run this. Then I'll run RCX and this type of window will open. What you need to do is select your particular GPDK library and just make sure that following parameters are set in this setup file. Similarly, you should check and see the extraction file, extraction tab. In this tab, just make sure that following parameters are selected and just click on OK. Then you can see the following message. Just click on close. Now we will do is file open, and we will open this extracted view which we have just created. Okay, So this was the extracted view. Now we'll click on OK. This is the extracted view. You can see there are some resistances and capacitances shown here. Now it has an extended view. The previous layout was without capacitances. Now the capacitances and resistances throughout your circuit are included in this layout. And now you can perform the same simulations as we have done in the previous lab for the transient analysis, and to find the delay and timing performance, and do the same checks. So you can launch ADEL, and from this you can perform the same setup that we did for in lab 1. And this completes our part 3 of this series. So I hope this was helpful. We've gone through the entire process of creating a layout for this CMOS inverter, creating the symbol, from placing transistors to simulating the post layouts. And in the next labs, we will perform advanced analysis on different circuits as well. And also, I'll teach you how to optimize those even further. So thanks for tuning in. If you found this video helpful, make sure to hit the like button, share it with your friends, and don't forget to subscribe for more VLSI content. See you in the next video.